So homework check tomorrow. Homework check tomorrow. So this homework probably won't take the whole period as usual. So guys, please use that time. Did I do my Albert I.O.? Maybe I should do this week's Albert I.O. Do I have any homeworks? Go backwards. Did I finish C21, C20? Go through your notebook and see. Because some of you are really unorganized at times, okay? So try to get organized. All right. So remember yesterday we were solving exponential equations. The first step was to get like bases. So I'm going to just word it a little bit friendlier. Make the bases on both sides the same number. That's a number sign, not a hashtag, y'all. Okay? And so we'll see some of the ones like we did yesterday, but what's added in today is some fractions. For example, if I gave you the number 1/9, let's think about what we could change a 9 to. Like, for example, 9 would be what? What base can we make a 9? 3. 3 to the what? Second. Thank you, Brian. Yeah. Okay. What about 1 over 27? You could make that 1 over... And if you don't know, it's okay. Of course, I know all of these pretty much by heart because this is my profession. I've been doing it for almost 30 years. You have calculators. You take different numbers. You try 2 to the second, third, fourth, whatever. You can't find it. Try 3 to the first, second, third, whatever. And Brian, what did you say? 3 to the... Did you say it? What? JT. Yeah. Right. It's not memorization. I let you use your calculators, not everything. So it's really important that you were able to take a fraction and make the number into a base, even if it's in the denominator, okay? Because then there's going to be a step after that, which is sometimes bringing the 3 to the second to the top, the 3 to the third to the top, the 2 to the third to the top. And that's going to be the only new part today. But so I'll come back to that concept. Let's start with one that we did like the type we did yesterday. So copy this down, especially if you weren't here yesterday. All of the problems were like this. Okay, so remember that first step is to get the bases on both sides to be the same. These are the bases right here. 2 is a base and 16 is a base. So that's all we look at right in the beginning. So the best method is to look at the smaller number, that's 2, and see, can I make 16 into a base 2? Sometimes the answer is yes, sometimes it's no, and if it's no, that means this one has to be changed too. There might be something they both have to be changed to. But oftentimes you can just change one. So what can we change 16 to be? 2 to the power of 4. Do I have to memorize that? No, I pick up my calculator. I know I'm trying to get a base of 2, so I do 2 to the second, 2 to the third, 2 to the fourth. And don't forget where your exponent key is. It's right here. It's called a caret. I don't know why, but it is. So 2 to the any power right there. All right, so understand. So let me just go back over to the side. I have done nothing to the left-hand side. I'm just rewriting it. On the left-hand side, so here's that 2. I changed 16 to 2 to the 4th, right? This is this. These are the same thing. And there was a exponent already up there. Don't forget, you have to bring it down, and we would multiply. So when I create a new power and there's already a power up there, we multiply them. But what's nice is, now that the bases are equal to each other, that means the exponents are equal to each other. So I can just bring them down on the ground, I guess is a way to think of it. They were up in the air. So I just brought this equal to this, and now I'm just going to solve for x. I'm going to distribute on the right-hand side. Get your x's together. Just what? Just never in real life. You don't ever want to get your x's together. It's not a good look. They start talking. Well, I just found out that my ex-husband just got engaged to his third wife. He's been divorced twice. He just got engaged to his next one. Good luck. Oh, I forgot I told you guys that. First time you didn't know that. He's a 2 to 12. Oh, I forgot I said that. Nothing. Okay, so you could have added 4x to both sides or subtracted 8x to. It doesn't matter, right? I usually try to make things positive instead of negative, right? So that's why I did that. So added 4x to both sides, brought down the 16, blah, blah, blah. I think you guys know how to solve an equation. Then we would add 20. You get 36 equals 12x, and divide by 12. So the final answer is 3. So just think about it. You just solved this crazy looking equation right here. The answer is 3. Okay? I'm going to give myself more room. All right, so that's what we did yesterday. Okay, that was the type we did yesterday. The only thing I'm adding in is you might have some fractions as bases. So let me show you. 1/9, for example, to the power of x minus 5 equals 27 to the power of 6x minus 10. Okay, so write that down and take a look at it. So my bases are 1/9 and 27, right? Those are the bases. 1/9 and 27. I need to make them be the same number. So pretend the 9 is not in the denominator. Let's ignore that. Let's just pretend it's a 9, okay? So 9 and 27. Can I make a 27 into a base 9? If you want to try that first. So 27 to the first, no. 9 to the first is 9. 9 to the second goes immediately to 81. So there's no way to make both of these a 9. That means they both have to change. Well, you guys already know how to change a 9. We just talked about it. That would be 3 squared, right? So 1 over 3 squared. And 27, we talked about that already. That's not in a fraction, so I'm just going to make it 3 to the third. If there's already a power up there, we multiply. So in all the problems that we've done so far, we would be ready to go, right? We'd have the same base. But we're just not quite there yet. What we need, because this is 1/3, right? And this is 3. Do you guys remember how you bring a number from the denominator to the numerator? You're allowed to do it as long as you do one thing. Does anybody remember? Sarah? I do what? Oh, here? Oh, thank you. Good catch. Thank you. But Sarah said you had your hand up. Do you remember how to bring the 3 up? Maybe, you know? Say it again. No. Okay, it's just really simple. Let me use this as an example. To bring the 3 up to the top, all you do is bring it to the top and change the sign of the power. That's it. Remember, we've talked about it before, but let me revisit it. The fraction bar, listen, the fraction bar, if you cross it, so if you have a number in the bottom and you want to bring it to the top, you can do that as long as you change the power sign. If you have something on top and you want to bring it to the bottom, you can. It just changes the power sign, okay? So this 3 squared is going to come up and join the 1 times 1 is just 3 squared, and that's going to be a -2 when I bring it up. It just changes the sign of the exponent, and we have a 1 left over in the denominator, right? If you had to think of it like that, we don't need it. Okay, so anytime you want to bring a power, watch, I'll do it again. Bring a power to the top, or just crossing that bar at any time, it just changes the sign of the power. Bring that up, it would become 2 to the -3. The base doesn't become negative, the exponent does. Okay? Now that our bases are the same, we can just solve for x in the numerators. So I have -2 times x minus 5 equals 3 times 6x minus 10. distribute, self-corrects. Right, -2 times -5 is 10. Get your x's together, just not in real life. You can add the 2x or subtract the 18x. Doesn't matter. Leaves you with 10 equals 20x minus 30. You could absolutely combine some steps. If you just glance at how many steps this is, I'm showing every little step. There's some places you could cut corners if you felt confident enough, but I'm going a little slower for those that might need it. Sometimes we need a little help. But I don't think many of you, if any, really have a hard time solving equation. Finally, the answer is 2. One more. We need practice with that power stuff. Last one, though. This was a little shorter. I'll actually show you on this one where you could cut some corners, not make it as many steps, if you feel comfortable. Of course, I would never tell you not to show more work, okay? So don't feel like you can't show more work. Okay, so if you're a fraction, ignore that you're a fraction. Just look at the number, 4 and 8. I think we all know what base they can both become. 2, right? 2. So this is going to be 1 over 2 squared. And 8 is going to become 2 to the 3rd times that power that's already there. Now, why is there parentheses on the side? Because we're saying the whole fraction, the numerator and the denominator, get that power. And you can simply move this guy up so that we have, like, this is 1/2 and this is 2. That's not the same base. So to bring this up, no big deal. Just put him on the top. He's now on top, except we're going to make his power negative. That's it. That's the only new part of this. And then we would solve it. So here's one easy place that you could cut a whole step out, which is a lot of writing, is as you write it down, distribute. Go ahead and distribute now, like in the error, and then write it down. So -2 times -3x is positive 6x, and -2 times positive 3 is -6. Same thing here. I'm going to get my x, I'm cutting some corners here. I'm going to get my x's together and get my constants together, all in one step. That would be 6 equals 6x. Okay, so if you're feeling like this is too long, I can do this so much easier. Like I said, do as much work as you want to or you need to, and there's some places to cut corners. Okay, so we are on page 18, and I'm going to do the first few with you in case you want to. Question on that? You're good? All right, let's get homework page set up. We're on page 18. We were on page 17 yesterday, so just flip her over. And they're not all fractions today. There's only 2. The other ones are just like what we did yesterday. So I'll do the first few with you if you want me to, and then we can finish it. This is C22. Yesterday. Page 17. Does that seem right, guys? No? Alessi? Oh, wait. Today is 21, right? I'm so sorry, Mariana. You were right. Alessi, is that what you're saying today? Yeah. Sorry. I'm sorry. C21. C21 today. Yesterday was C20. I have it written here. I just didn't pay attention to it. I don't know. You never know what's going through this girl's mind. What's left of it. Okay, no fractions. Yay. Just back to what can I make my bases? What can I make? Like, can I make a 64 with a base 8? That's what you want to try first. Because sometimes there's multiple. Like, you could make these both a base 2. You can make them both a base 4. But that's more work than just changing one. So that's why I say the first step is, can I make the bigger number have the same base as the smaller number? You can, right? 8 squared is 64. Don't forget the stuff you already know. So I don't even have to change this side. And this side is just 8 squared. Bases are the same. Set your exponents equal to each other. Okay. So 4x plus 2 equals 2. Can you get 0 as an answer? Of course you can. Yeah, 0 divided by 4 is 0. It is what it is. How are you feeling about these? Wait, what number is that? That was 15. Gosh, Tracy, get it together. Yes, teachers have real first names. Most people in my life don't call me Mrs. Morse. They call me Tracy. So it's weird. I remember when my son was really little, we were at Publix, and we live in Tampa, like West Chase area. And one of his teachers, well, yeah, it makes sense. One of his teachers must have lived in the area, and we saw her at Publix. And he was mortified. He was like 7. He's like, what is so-and-so doing here? I'm like, what do you mean? He's like, that's my teacher. Why is she at Publix? And I'm like, teachers eat and cook meals and whatever. And he was like, oh my God. Oh my, like, we still teasing about it. Okay, can I make 125 into a base 5? I don't know. Pick up my calculator and see. Yeah, good, Dylan. 5 to the power 3. You don't have to know it off the top of your head. Understand that, okay? Pick up your calculator and ask it for help. And yeah, try 5 to the first, 5 to the second, 5 to the third. See if you can get 125. I'm not going to give you a problem where it can't work yet. Okay, so now that the bases are the same, that means the exponents are the same. And we can solve for the variable in our exponent. Good. I'll do one more. If you want, do you guys need me to do one more? Anybody?
Yeah.
Yeah? Okay. What number? The next one, right? Yeah. You did it already, Mandy? It's -4 is the answer. Okay, big number. Big number. We may not know much about 625. That's what calculators are for. And if you want to change A to X or whatever your favorite letter is, go right ahead. Doesn't matter what variable you use. So you want to ask yourself, could I make 625 into a base 5? So you pick up your calculator and you find 5 to different powers. So 5 to the 3rd. That's 125. 5 to the 4th. There it is. 5 to the 4th is 625. Got it, Andy? Oh. Sorry. Whatever. Is everybody back there okay with that problem? Yep. Okay, so there's 17, and then the rest of the problems with the answers.